Everyone, this is Mr. M from Algebra Lessons. In this small video, I'm trying to help you with direct and indirect variation. Direct and indirect variation. Okay. Simply speaking, direct variation means if okay, this is age on the y-axis and time on the x-axis. As time goes up, what is happening to age? That is what the simple explanation for a direct variation. So one factor is going up or down, the other factor is actually going up or down. That means based on one factor, the other factor is also changing positively or negatively, same as the other factor. So time goes up, age is also going up. That is actually called one example of a direct variation. Okay, let me give you another example. Okay, this is the quantity or measure of let me change the axis. Okay, let me change the axis. Okay, so this is actually time or distance, and this is the measure of gas, or simply the petrol or diesel, okay, in your car or truck or whatever it may be. Okay, as distance goes up, the amount of gas, as distance goes up, amount of gas is actually going down. So how can we express that? Say for example, this is the kind of a graph that you can draw for that particular. Say for example, see at this point, if I covered 5 miles of the distance, my gas level is here. Again going up, if I reached 10 miles, say my gas level is actually here. Again going up 15 miles, the gas level is going down. So this is actually what is called the indirect variation. At the same time, see what's happening here. Time, say for example 1 hour. Sorry, this is age and time. So the time, 1 year. My current age is here. Another 1 year, age is going up. Another 1 year, age is going up. So this is going up, this is also going forward. Okay, this is actually what is called the direct and indirect variation or graphical explanation. Okay, let me simplify some some algebraic expressions, how we can express algebraically the direct and indirect variation. Say for example, if the direct variation can be expressed like this: x is directly proportional to y. X is directly proportional to y. This is the way you can express algebraically the direct proportion. And the indirect proportion can be written as x is proportional. Inverse proportion or indirect proportion can be written like this. So if it's an indirect variation or indirect proportion, we will express like this. If it's a direct variation, we will express like this. Okay, but for the simplification part, it will be very easy. It will be very difficult to handle the proportion sign, but we can convert this proportion sign into an equal sign by putting a constant there. So I can write x is equal to ky. Here x is equal to k by y. See, this is the way you can simplify the direct and indirect variations. Okay, so if you can see an expression in this form, x equal to ky, x and y both on other side of the equal, both sides of the equal sign, and one variable is multiplied with the constant, and you can say that that's a direct variation. And see, x and y multiplied together, that is equal to a constant. This represents an indirect variation. This expression is simply wrote in this form. So x is equal to k over y. So this is actually the way to find, easy way to find. That's actually a tip, not kind of a systematically proven method, but that's a tip. If this x and y on both sides of the variable, sorry, both sides of the equal sign, and multiplied with a variable, multiplied with a constant, so it's a direct variation. X and y multiplied together is equal to a constant, indirect variation, or x equal to the constant over the other variable, that's also represents the indirect variation. Okay, let me do some problems. Okay, so x equal to 5 when y is equal to x equal to 5 when y is equal to 8, and x and y are directly varies. Okay, then find y when x is equal to 8. Okay, this is the question. Okay, so it is saying that it's a direct variation. Okay, so let me write this expression. Okay, here. So if it is direct variation, x is equal to k y. Okay, now what it is simple to solve this kind of direct and indirect variation problems. So x is equal to ky. So x is equal to ky. You have x and y here. Plug it back here in this expression. X equal to 5 and y is equal to 8. So you can write as 5 is equal to k times 8. Find k. For that, eliminate 8 on both sides. So k is equal to 5 over 8. Okay. So write that expression one more time. X is equal to k times y. Actually, what's our question? We need to find y. You have x, now you have k also. Plug it back here. So x is equal to 8 equal to k is 5 over 8 times y. We need to find y, correct? So you need to eliminate this 5 over 8. So multiply both sides with the reciprocal of this fraction, that is 8 over 5. 8 over 5. Okay, cancel these two pieces. So the right side is y equal to 8 times 8 is 64. 64 over 5. That's your answer. So 64 over 5. So your value is y is equal to 64 over 5. Exactly the same thing you can proceed for the indirect variation. So if it is an indirect variation, x is equal to k over y. Okay, keep this in mind. X is equal to 7 when y is equal to 2. Find y, find x when y is equal to 8. Okay, so this problem we can solve using the same procedure. X is equal to k over y, because we have the values of x and y as the first line. So x is 7 equal to k over y is 2. Multiply both sides by 2. That will give you the value of k. So k is equal to 14. So k is 14. Now we need to find the value of x when y is equal to 8. So write that expression again. X is equal to k by y, and we know what is k and what is y. So then x is equal to 14 over y is 8. Yeah, if you need, you can stop at this point. Otherwise, you can simplify this again. I'm completing that simplification here. X is equal to 14 can be written as 7 times 2, and 8 can be written as 4 times 2. You can cancel the common terms. So the leftover is x is equal to 7/4. I hope this makes sense. If you are not a person subscribe this channel, please subscribe this channel and don't forget to press the bell icon to receive more videos of this kind. Thank you.